So just a note before we start today's session. So Ray has forwarded me the YouTube recordings for yesterday's session, and I'm going to put that up in our Slack channel. So please subscribe to the Brigade Infra channel, and where you can see all the links.
Okay, so I think the agenda item today was to do a deep dive in Buck, talk about the Buck fork that we have, as well as a little bit of Buck overview, as well as like some of the ways that we use it. So Buck's main website, buckbuild.com, has a bunch of kind of great documentation. So I'll just point out a few things here first. So the first thing is there's a few what we'll call core rules in Buck. One is, well, so what the core rules do is they basically help sort of form building blocks for you to build sort of generic rules. And then there's a bunch of sort of language or platform specific rules that can also be used. The thing with Buck is that it needs to be aware of every file that is ultimately a dependency of a build rule. It can either be made aware of files as including those files as sources for a particular build rule, or they can be exported to Buck directly and then depended on. So export file is just a way to make Buck aware of a file in your source tree that's going to be consumed by another rule. Again, this is only required in certain contexts where the rule is not explicitly a source of a rule. We'll see that probably in some of the booklets for packaging. Then there's general, which is basically a way to take a bash command and wrap it up in Buck so that Buck can execute the bash command.
So it can be pretty much anything, right? I can even write a Python file and then call using a Python something. Yeah. Okay.
Yeah. So it can be literally whatever. Now, if you wanted to write a Python file and then execute it as a general, there's actually some
Python rules.
There's some Python rules for building Python binaries, but yeah, you could write a Python file, export it using export file, then consume it in your general and run. Okay. So that's something that I think we've done. There's also this notion of remote files. So this is how you access files over the internet. So the way that we pull dependencies in for Maven Central is through a wrapper on export file. And then zip file is another rule. You could easily build zip file using zip in general, but allows you to create a zip package from a set of sources. So those are kind of like the high-level primitives you have for building what we call macros. The other rules that are interest here are mostly just Java library and Java test. So Java library is just got some arguments that you'd be sort of expecting, resources, sources, etc. We actually extend, and extend, I mean like Java extend the Java library rule to create the OSGI compatible jar. And so then, yeah, the two basic ways you have to extend Buck. One is what they call macros, and these are just writing Python functions which take any number of new parameters and then can call one or more existing underlying rules, so they're Java library rules, general rules, like file rules, whatever. So it's a way to take sort of a set of complicated or multiple rules and maybe some processing to get arguments for those rules, and just do it in one shot using Python functions. Exactly. And so, for example, like this one, Java library using Guava, basically just wraps Java library. It passes the name, sources, resources through, and then it takes one dependency, which is Guava in this case, and appends it to the dependencies that are passed in. So this would basically just be so that, if you didn't want to have to include the Guava dependency or something on every rule, you could do it this way. Now, the one thing to note is that these macros don't show up as build targets. So if you actually want to execute something directly or name a target, you have to refer to the names that you give the underlying targets. So convention is to at least have one underlying target that matches the macro, but it's not strictly required.
Okay.
The other way to extend Buck is this mechanism of creating your own Java rules. And we'll walk through some of the examples we have in ONOS. But what we've done is so you don't have to go and modify, basically to modify, add build rules to Buck. They say you have to fork the project and modify the source. So that's not like the most ideal thing to do. They also promise that at some point they're going to have a beautiful, elegant extensions API, and hopefully maybe something like Lava has, or like Bazel has. But for now.
So custom rule doesn't assume that I'm going to add a rule to support a new language.
Sure. Exactly.
And that comes in custom rule, not in macro.
Well, yeah. So if you want to write a rule to support a new language, you have two options. One is figure out whether you can invoke the compiler or whether you want to invoke the compiler using a general, and then pass the sources in and have it produce some output. That's the most roundabout way of doing things. Sorry?
That is the most roundabout way of doing things.
Well, so yeah, it's the sort of path of least resistance. Like if you just have a compiler, like for example, if you wanted to add protobuf support to this, you could have the protoc compiler in a gen rule take a bunch of proto files and spit out your language target specific files if you wanted to. Now, the thing about gen rules is that gen rules don't have a ton of visibility into sort of the parameters that you have. Like, there's really just sources, source directory, out.
It's supposed to be just a general rule.
Yeah, so it's fairly limited. You can get the path to target, the Maven coordinates, whatever, but you can't really like reach into other rules and figure out kind of what the dependencies of other rules are in the same way that you can do from the Java API. So there's a couple of rules, like for example, the OSGI wrapper. We need to get some of the dependencies from the Java rule that we couldn't necessarily see otherwise. So that's an example of something we implemented. Another example is we implemented check style as a custom rule to do the check style verifications. But what we did is we, instead of having to sort of recompile and redistribute the entire Buck executable every time we wanted to change a plugin, we added just a really basic plugin API where you can have jar files that register with Buck on startup. So here's the fork that we have, and there's a file in here somewhere. It's in source. So somewhere in here.
So I thought you implemented OCA, you have the macro. No?
It's both a macro and a custom build rule.
Okay.
We'll get there in a second. But I just want to show you quickly how this gets loaded. So we have I think we want so in here. All right. So basically, we have this plugin manager that we introduced. This plugin manager will search a predefined directory. In this case, that predefined directory is part of Buck config that we looked at yesterday. It will look at all the jars in there, and then in all the jars, it'll go through them. It'll look to see if there's any classes in those jars that extend the build rule description type. For those that do, it takes the build description and then registers it with the known build rule types factory. And so that's basically making this call on your behalf. So all you have to do is just update a jar in a particular folder, and then the next execution of Buck will load that known build rule into the environment. Now, what Buck does is Buck's core is a Java platform. If you look at sort of the project overview, it's mostly Java, a little bit of Python, a little bit of JavaScript. That's for the website stuff. But basically what happens is the Buck sort of runtime is or user-facing runtime is Python environment. And so based on the known build rule types, Buck generates a Python executable, or sorry, a Python library, which is all of the default build rules that show up as just Python functions. And so when you invoke a native build rule, there's a auto-generated Python function that's built based on the description, the rule description that's provided, and then that is routed into Buck using, I believe, just a JSON REST API. I forget exactly the mechanism by which it routes it at this point, but those Python calls are routed into Buck, and then Buck uses that to build up, during the parse phase, build up the graph of dependencies. So perhaps we can get started by looking at just a custom build rule. So in Buck plugin, we have a couple of files. The first we'll start with is a description. So as I mentioned before, the descriptions are what gets registered with Buck, and this is how build rules are populated. So these descriptions are not actually going to do any work. They're more like receivers and carriers of data. They're the bridge between the Python interface and the Buck core, exactly. And so we'll go to the bottom where sort of the interesting stuff is. Every description has an arg static class, which is basically all of the parameters that are going to be exposed via the Python API. The convention is that this is in camel case, and then when the Python API is generated, it converts camel case to the snake underscore case. But in this case, like I said, our ONOS jar description, which is really just the OSGI wrapper with some ONOS specific stuff, that's based on the Java description, Java libraries description. So Java library, as we mentioned before, add sources, resources root, a manifest file, etc.
So this is part of the original Java rule.
This is the original Java library that's available in Buck, and we've just extended it to add 2 extra parameters. Some of these API title, version, package stuff, this is Swagger related. The group ID, bundle name, version, this is OSGI related. And then the import packages, export packages, these are directives that can override the defaults for the bind bundling, which ends up in the manifest. And then, so basically what happens is when there's code that gets auto-generated to auto-populate these arg objects, and then when somebody invokes a build rule, this create build rule method gets called. And so you get the graph, you get the params at a resolver, and then you get the args object that was constructed based on the call that comes in. And so from here, there's some context that we can look at, but basically, you know, sometimes we basically overloaded this method to produce the Maven jars, which are just a special wrapping Buck needs to be able to publish them.
Oh.
Well, I guess
Buck by default cannot publish Maven jar.
Buck needs, so Buck by default cannot publish Java libraries because it doesn't have context around Java libraries, but it has this concept of a Maven publishable jar or something, which has Maven coordinates and a little bit of metadata. And so a Maven jar basically just consumes a Java library or Java binary and then is able to have enough context to publish it. So in the case of Buck, they allow you to what's called flavor rules. So you can ask for a Maven compatible one or a non-Maven compatible one. You can say, I know it's a Java library, but I just want a sources jar back. I don't want a classes jar. Or I want a Javadoc jar back. I don't want a classes jar. And so we basically will look at what flavor was passed in. This is like hashtag sources or hashtag Maven or hashtag Javadoc when you're actually invoking the rule. And then this is where we disambiguate based on the flavor you ask for, what rule we give you.
Okay. And this is the base for your Buck publish command.
No, Buck publish. Well, so Buck publish command, if you try to ask it to publish something that is non-publishable, it just throws its hands in the air and says, I can't publish this.
Oh, okay.
So one way around that is when we publish, we just ask it, we flavor all the rules, hashtag Maven, and those rules then get wrapped when we actually construct the underlying Java library.
Okay. So even the Buck publish was not part of native Buck project. So
No, Buck publish was part of the native project.
Okay.
We just made some small enhancements there to get it to talk to sonotype.
Okay.
But yeah, Buck publish is there, and it's probably been improved slightly. But basically, all I was saying is that if it's not a Maven jar, we just give a regular one. If it is supposed to be Maven related, we more or less just wrap it. It's the same set of parameters in both arguments. There's also this issue where you may want an OSGI compatible jar or non-OSGI compatible jar. The thing is, for Buck, it doesn't like the fact that you can have this web / root, like a web directory root, that completely messes up all the class file locations. And so for dependencies, for compilation purposes, we use the non-OSGI wrap jar. For publishing, we use the wrap jar because the OSGI environment does know how to deal with the web context. But anyway, the point here is not necessarily to walk you through this specific rule. This is probably one of the more complicated ones. But the idea here is basically just to say that this args, to kind of show you the code flow. And the point is you have this args object that gets auto-populated based on a Python call in a Buck file. That comes into the create build rule, which basically takes that arg file and builds the underlying rules that are actually designed to do work. The rule that gets created in our case is this ONOS jar rule. That call happens here. So we basically take a bunch of context from the build environment. We take the parameters that you passed us. We blend those together to provide this object called ONOS jar, which has then got enough context to make the underlying calls to, in this case, the bind plugin. Also to do like the Swagger generation and some other stuff. But this object is basically the rule that is going to exist for, like, at the time the core is doing the execution time. steps. And in this case, we decided to split up the step factory, which is basically the steps. So the rule doesn't do the work. It provides a list of steps, which are basically just thread executor things that are going to run, do some work, and those get spun up and torn down by the build executor. So step factory, for example.
But when you said that one doesn't like the web enough way of organizing things, but then how the web GUI part of ONOS is getting built?
Right. So what I said is that the jars that have the web in prefixes on all the entries. It's not really Buck that cares, but the Java compiler does not like jars that look like that. Doesn't know how to parse them or understand them, as far as I know. And so we produce two flavors of these jars. One flavor is the non-web jar, and the other flavor is the web-imp jar. When we're doing compilation, we use the non-web-imp jar. So as like a compilation time dependency, we use the non-WABD jar. For runtime and for publishing, we use the WABD. But yeah, basically we generate some Swagger sources as one of the steps. We do the Java compile. We create the jar. Then we pass the jar through the OSGI wrapper step, which is basically just an executor on the Maven bundle plugin. And then we spit out the output of the bundle run. So there's a lot of, as perhaps you can sort of infer without going into too much detail, there's a lot of context that you have here. You can resolve source paths to actual files in the file system. You can look at a module's dependencies. An example of that. You can look at a module's dependencies. You can do more sort of analysis around what type of file something is. You can open it up. You can sort of build more logic in, perhaps, than you would otherwise. And so, yeah, in the case of ONOS, the ONOS jar, which does the analysis for bundling, we have to pull a lot of stuff out of the underlying Java library rule. So, and also the flavoring, being able to produce sources, JavaDoc, and the Maven and the WABD and non-WABD jars also need. It's just sort of easier to do it within the context of Buck. So, yeah, learning curve is a little bit steep, but it's a much more powerful API and performs a little bit better, especially if you have to spin up JVM resources. So that's sort of the complicated introducing new types to Buck. Now, once you have those types, we have this directory called bucklets, which basically just means macros. They're called .bucklet. That doesn't really mean anything. They're really just Python files.
So who coined them?
So there was a couple of projects who started using Buck, like Garrett and a few others. And people who were building these macros coined the term. Yeah, they just said bucklets, little macros, little reusable macros that add new sort of buildable functionality. Now, the separation of concerns difference from our perspective for something like the bucklet versus, or the macro versus the build rule. So the build rule is like, somewhat generic, tries to be, I mean, in the case of ONOS, it's kind of project specific, but it's not module specific. In the case of the macros, what we try to do is we try to sort of infer or inject sensible defaults when a user doesn't want to override them. And so you'll notice that for many applications, go back to reactive forwarding. We looked at that one yesterday. All that's said here is OSGI jar with tests, steps, compile deps, right? So we just looked at the previous build rule, and we're supposed to have a sources, a resources, a web context, all this stuff. And it's not necessarily provided via the debug file here.
So that can be taken as assumed, or it will take default.
Right. And so what does the default mean? Well, the default in the debug build rule types is none, or optional.empty, right? And so what we do in the bucklet is we'll take a look at whether or not the name parameter exists. If you don't give your build rule a name, we'll infer a name. And by infer a name, I mean we'll just take the path of your directory and we'll replace the slashes with dashes, and now you have ONOS dash apps dash forward. So we build the default name for you.
And this name only is given module.def. So I understand correctly.
Sorry?
You just open modules.def. Yeah, so here that is the name dimension, right? ONOS slash. So instead of slash, you are replacing the hyphen here. This is what you're telling, right? ONOS slash app slash mobility.
Yeah, so I guess what I'm saying is, like, the anatomy of a build rule is its path in the workspace is the first part. And then within a buck file, every rule has to have a name so that you can disambiguate between multiple rules in the same buck file. And so rather than one thing we could do is we could just have everyone who builds every build rule provide a name for the rule that they're wanting. The reason we didn't do that is because we wanted to make it sort of as easy as possible to generate these build rules, just getting started. And so we just kind of went with more or less the convention that is imposed by Maven, which is to just basically, well, whatever, it's not really a convention, but it's just a hierarchical name that was similar to the ones that we were publishing with the Maven built artifact. So in this case, this one says -OAR. We'll see why that shows up in a second, but the OSGI jar that we're building has just this name. So path apps DHCP, and then target name ONOS apps DHCP is sort of the default, unless you specify something else. So the other thing is, we didn't provide sources in that rule. So what are the sources? Glob basically just takes a base path and auto expands, kind of like a regex auto expanding. If resources again is not present, we'll do that. Something to note here is you'll see there's this none versus none. We introduced this notion of like capital NONE, which is just a string with value capital NONE. The reason we did that is we wanted to be able to distinguish between a user providing none explicitly versus a user
providing the value.
Omitting the value, yeah. And so by default, omitted values, if they aren't auto-assigned, will be none. So, or whatever you provide over here. So that was basically just a way to provide a sentinel value that wasn't none, so we can disambiguate in certain contexts. But we'll also build the Maven coordinates based on group ID, name, version. And so, yeah, we build up a little bit of context from sort of inspecting the environment. and then providing sensible defaults if the user doesn't want to include them. And then we actually invoke that build rule we were just looking at. So we provide the name of the rule, we provide sources, the dependencies, all that stuff. We'll also include the OSGI specific stuff, bundle, version, license, description, import packages, etc. And then the Swagger stuff, API, title, version, package. So these will map to those hard descriptors that we saw before, which get passed in through to the build eventually. There's a few other rules that we'll build on your behalf. For example, we build a check style rule. We'll build a JavaDoc rule. We'll build what we call the local install rule. So if you want to be able to install these artifacts into your local N2 repo, we have a general that'll do that for you. There's also a wrapper. I mean, you saw the other one was OSGI jar with tests. Sort of now there's test sources, test dependencies, etc. You can see that these things, it's possible to wrap them together. So, you know, this macro, the OSGI jar with test macro, calls the OSGI jar macro, which then calls the build rules. It also calls check style, or check style in the sources, sonar, which is a job to do sonar analysis, and then Java test is a rule that's a native build, native bug rule. So yeah, basically you can think of these macros as just being wrappers that can, you know, take some information about the environment, use values in certain ways, and then provide easier to call APIs so that you don't have to. So if you find yourself like repeating yourself across multiple bug files, it probably means it's time to build a macro. Okay. So there's also this remote jar. Maybe we should have started with this one because it's a bit simpler. But so remote jar is a macro that we use for getting artifacts from Maven Central. Basically, we take the remote file rule, and we'll use that to get, based on the URL, get a Maven artifact from Maven Central. Buck wants the SHA of those Maven artifacts, or any remote file for that matter, so it can tell whether the bits are changed or not. It can't produce a deterministic build if it doesn't know the hashes or what they're supposed to be.
Okay. Few weeks back there was a mail chain in mailing list that Buck, you can install Buck without internet connection. Like, it can build all the dependencies in standalone mode. But then if we have this remote jar, then are there any projects that actually require dependencies downloaded from internet?
So at the moment, every single module, more or less, maybe a few don't, but almost every module depends on some third-party dependencies, and the way that we get all those third-party dependencies in this project is via remote file. In certain projects, what they'll do is they'll actually download the jars for their dependencies and check them into source. We haven't done that because I think generally having binary files checked into version control is like not the best practice, but
so without internet connection, it's not possible to build units in Buck.
Without internet connection, what you'd have to do is you'd have to run buck fetch, I think is the command, to pre-download all your dependencies. And then once they're in your local Buck cache, then you can build. Okay. But yeah, without internet, you'd have to pre-fetch your dependencies. Or just running a build all the way through, have all your dependencies pre-fetched, and then from that point on, you don't need the internet to build. Okay. But yeah, so this is, remote jar basically says remote file. So this grabs a file from the internet, and then pre-built jar is just a way of, so remote files don't have like any sort of profile. Buck doesn't care about them, doesn't know what they are. They can't be used, for example, as a class path entry. They can't be used because, I mean, in certain cases, like in Java, you want to know what the Maven coordinates of stuff is if you're like building a features file or something else. So pre-built jar basically just wraps the remote file that we built here, gives us the Maven coordinates and makes it publicly visible. I guess that's another thing sort of perhaps worth noting. By default, buck rules are only visible within a buck file. There's this magic string called public, which makes them visible to any other target within the project. And then you can also pass in a list of targets that should have visibility to this particular target. If, for example, you wanted to restrict who could depend on something to a smaller set of things, you could put some restrictions by providing a list. So another thing perhaps worth noting is we've got some facilities mostly using gen rules to generate features files. So these are the files that, they're XML files that build up the lists of bundles that need to get preloaded. We have a little...
this actually imitates an app.xml, features.xml in Maven.
Yep. So we have a features macro. Also, features are just, snippets of the features XML OSGI feature group that puts multiple of those together. ONOS app. This is capable of building the OAR package with a features file, app XML, and the bundles all present. So getting like 1,000 phone calls apparently at once. Mute. Sorry about that.
I would ask one thing I forgot. Okay. So basically, yeah. So basically, you are building a jar and then wrapping it with OSGI, and then again wrapping it with ONOS app to become an OAR, and then you're publishing it.
Well, so yeah. So for every bundle in an application, it gets wrapped with the, so we use the OSGI with those. For example, we'll pick a different app, which is slightly more complicated. So the HTTP app is a multi-bundle application. And so what we'll do here in this case is we use the OSGI jar with test macro. This produces several targets. It produces a Java test target for the test sources. It produces a OSGI jar target, or ONOS jar target, which is the wrapped jar. It produces a check style target. It produces Javadoc target, etc. I think we can actually look, for example,
No, like speaking from Karan's point of view, right? All it needs an OSGI compatible jar, like a jar that contains the OSGI manifest.
Yes, that's correct.
Yeah, but then why are we actually adding this app.xml and feature.xml? It's just for the application of system, nothing to do with Karan?
So it depends upon what level of the API you want to work with. If you just want to have OSGI compatible jars as just like jars that have OSGI compatible manifests written into them, and you want to directly say bundle install.
Okay.
So you can't use feature unless you build a feature, right? So if you want to use the bundle level subsystem, you can install, start, stop, and uninstall bundles directly.
Using
Plain old OSGI jars. So if you want to use the bundle subsystem directly, you can do that. Now, most people don't use it directly. Most people prefer to use the feature subsystem, which enables you to load and unload groups of bundles. So all a feature is a group of bundles, and features also allow you to define dependencies on other features. So for example, ONOS, most apps require ONOS API. ONOS API requires the ONOS API bundle as well as a ton of dependencies. And so when you build these features, you can say ONOS core dependencies. So ONOS core dependencies is one feature. Then ONOS API has the bundle and core dependencies or something. And then ONOS app is a features file which depends on ONOS API and a bunch of bundles. So this feature mechanism is basically just a way of creating groups of dependent bundles, and then loading them using feature install, feature uninstall, etc.
Okay, so for feature install only we need this app.xml and
XML? Just features XML.
Okay, so that is app.xml then.
So app.xml is a made-up file format. Like it's a proprietary ONOS specific file format that you can blame Thomas for. Just kidding. We work together on that. But no, it's a proprietary ONOS format that provides the metadata about the app application.
For all the application system of ONOS.
For the application system of ONOS.
Okay.
So the app XML basically just describes what are the features that this app is providing. So then it'll use the features calls on the Java API side rather than the CLI side to do feature uninstall, feature install. The other thing is we provide like the app description, which shows up in the UI, the app name, which shows up in the CLI and the UI, the type, etc. Like so, all the parameters of an application are provided in this app XML. Now, the way that we created these packages originally, and this isn't necessarily the way it has to be going forward, is to have the app XML in the top level directory and then to provide the artifacts in the subtree, the Maven style subtree, so it's easier for us to just kind of overlay that onto Carafe. And so Carafe can find the features file and the bundle file more easily. Logically speaking though, like you could just provide some metadata about those files. So, you know, we chose to embed the metadata about the Maven coordinates into the file system because from a jar tar perspective, it's just really a map anyway. So we encoded that metadata into the file system. And by metadata, I mean group ID, version, artifact, name. So that's just embedded in the file system. But it could have been done in a sidecar file. It could have been done in the app XML file for that matter. We could have chosen to put the app XML file into one of the bundles. But the question is which bundle? Because you can have multi-feature, multi-bundle jars. So yeah, I mean, basically you can think of app XML being for ONOS application subsystem, features being for the feature subsystem, and then you just have some low-level bundles for everything else. So I just wanted to show you before.
Yeah, just before we go ahead. So the reason why I asked this question is, we started off with OSGI, and then we moved to understand the thought process correctly. Probably would have started off with OSGI, and then we would have thought that, okay, we are going to have an application subsystem that takes care of the lifecycle management of all apps across different nodes of the cluster, and then we introduced this app.xml. At that time, Maven was there, so we are following that ideology. Now that we are in the bug, we are actually trying to put the Maven ideology inside bugs by writing some buglets or extending the genetic rule, something like that. But are you open to actually move from that ideology to bug-based or JSON-based ideology, or are you still going to follow this Maven path?
So I don't think we're tied to ideology in any way. I think the biggest remnant of Maven ideology is just in the way the modules are laid out, more or less. Buck doesn't care that sources are in source main Java, blah, blah, blah. Maven does. So if you wanted to restructure the project's file system to, you know, use different source main, source test, whatever. I mean, that certainly could be done. Although, I mean, having some conventions, like it's not necessarily that bad of a convention. So from a file system layout perspective, from the source code side, we'll probably continue to use the Maven thing unless there's a compelling reason not to. This notion of having OSGI jars and features files and app.xml has nothing to do with Maven.
Yeah.
So the manifest format to create an OSGI bundle is specified in OSGI, not Maven. The
point I'm trying to make is Maven was actually OSGI compliant. So
no.
Right, but we already had Maven bundle present. So
Maven bundle plugin, right?
Yeah.
Someone wrote a plugin for Maven that builds OSGI compliant jars.
Yeah.
The bundle plugin uses a library called bind, BND. And what you get out of that is you get a OSGI compliant jar, right?
Yeah.
So we have now a similar plugin, if you will, called ONOS jar, right, which uses the same underlying library to produce artifacts that are OSGI compliant.
Okay.
So there's also a bundle plugin for Gradle. There's a bundle plugin for Ant. You can run bind standalone and just use a standalone jar, the bind jar directly to wrap your artifacts. So this notion of Maven being OSGI compliant, I mean, then you'd have to say, you know, Maven is, you know, Java compliant, and Maven is, you know, some, you know, crazy other format or target, or, you know, it's gRPC compliant and it's proto compliant, right? Just because it's proto compliant gRPC, you know, like it's Maven is a framework for Maven's a framework for doing builds, and it has, I mean, I'd say Maven ideology is hierarchical POM structure. Maven ideology is this notion that
dependency management.
You got dependency management. You've got ability to have build phases, the precompile phase, the compile phase, the gen sources phase. There's several phases that Maven defines, and plugins can inject work to do at any one of those phases. So I'd say that's kind of the Maven ideology, which we're kind of more or less stepping away from in how the Buck build processes the world. But yeah, I mean, I don't see us moving away from sort of OSGI jars, using features to group those, using the Felix SCR libraries to build components and inject the XML file to describe those components. Okay. As I mentioned yesterday, we're working on a way to have the single bundle jars that don't need to be wrapped in OARs, where sufficient amounts of the metadata would be embedded in the jar file. But yeah, I mean, we'd have to find a way to encode the information about the apps to ONOS anyway, and I mean, unless there was a compelling reason. I mean, it's certainly open to compelling reasons, but it could be done, you know, in something other than the app.xml file. But there would be some work to just, you know, on the application subsystem to reparse something. Sure. Is that kind of good?
Yeah.
Answer your question?
Definitely.
So we looked at one. This is the DHCP apps API bundle. So now we're looking at a multi-bundle app.
Yeah.
It's got OSGI jar with test, a single macro that gets called. But if we ask Buck what targets it thinks exist in this Buck file, it returns a whole list of them. Mm-hmm. And so a lot of these are ones we saw earlier. So the ONOS apps DHCP API, this was the main OSGI compliant jar that we looked at. There's also the registration of the check style files and the check style test. There's the rule that I mentioned if you want to install this bundle into your local M2 repository. there's the Javadoc target, there's a sonar target for doing coverage, the test target, and then the check style file registration, and the check file execution, and then sonar for the test as well. So from Buck's perspective, by the time these macros get expanded, we've got 10 targets, but most people will just use the first one main target.
And if we don't use OSDA jar with test, instead of use OSDA jar, probably we won't be having this, right? Only the first one we'll be having.
Yeah. So if we change this, and sure we can do that. Why not? So if we said just OSGI jar, and we reran the targets thing again. So yeah, we just get the first set of rules without the test rules.
Okay.
So this is a case where we have one bundle defined as API, which is going to be some sources that can be imported by other modules, and then another one which is the application implementation.
But it is more or less like good way to do things like it. It is not a hard and fast rule that every app that is going to write, I should split as an API bundle and implementation bundle. It's like a process or.
So it comes down to how you want to design your modules. If you want to design your modules, if all your app is doing is it's implementing some logic, and it doesn't have a service that it's going to expose to other applications, then it's perfectly fine to implement it as a single bundle. If you're going to define if you're going to define a service API and you're going to define some objects that are going to be used passed as parameters, input or output across that service API, generally speaking, it makes sense to split it out, because then someone who depends on your app doesn't have to depend on your implementation. They also won't accidentally start reaching into your implementation, right? They can just depend on your API bundle, and then the implementation will be present at runtime, and it'll get auto-wired using the OSS. So we have another example here of a slightly more complicated file. This one, we provide a web context because DHCP has REST interface, exactly. And then we also provide the API title version stuff. This is for Swagger. So this gets auto-generated and push-in. So we've got two OSGI compliant jars. This one's going to be a WAB jar, and this one's going to be just a regular OSGI jar. We can show you that. Build ONOS apps. So we get two jars here. It's just a regular old OSGI jar. If we crack open the manifest, which we won't do, we'll see the import export package, bundle symbolic name, bundle name, etc. If we look at this one, we'll see we get the WAB compliance, web inf classes prefix on all the entries, and this is what makes the compiler upset. You'll also note that we have a shell config for the CLI stuff. We'll have, there's three, I guess, components that will get loaded. The doc registrator, this is for Swagger, a store.
So where do we configure that? We need to cook two versions of this. Yeah.
So earlier we talked about flavors. So you can ask for a flavor here. of this. If I can remember the flavor correctly, it'll work great. Might be a dash in there. Yeah. So, our description. Yeah.
So by default, it will split to 2, and if you want something, you can specifically ask it by adding this line.
Yeah, so you can specifically ask. So, so if we say jar tf here, you get the non-WAB jar. Also, we can ask for, like a sources jar. Might be SRCS. And so then this jar is going to contain the Java source files instead of the compiled class files. So yeah, different ways to add flavors to the jar to produce slightly different outputs based on the same set of inputs. Okay, so we looked at the fact that we have the OSGI jar for an API, we have an OSGI jar for the implementation. Now pulling this together to a single ONOS app is done. In this case, we did it in a different buck file. Technically speaking, you could define all of these high-level things at the top-level buck file. But yeah, we have two bundles. These bundles have the names of the targets that we saw earlier. DHCP API, DHCP app, located in API and app. And then we create an ONOS app, which has a title, category, URL. We could have provided more parameters here, and then also included bundles. So these are the bundles that are going to get packaged alongside this app. Okay. And if we look at targets again, what we'll see is that this ONOS app target produces three files, or three sub-targets. One is the app.xml sub-target, so this is going to generate the app.xml file. The feature sub-target, which will generate the feature XML file, and the OER one. And so if we were to say app.xml, output, we'll see that there's the app.xml file that gets generated. This contains the two artifact descriptions, as well as a reference to the features file for this particular app. This is sort of similar to what we saw yesterday. We have the features file, which this is the graph compliant features descriptions, which has a name for the features file and a name for each feature, and then it depends on ONOS API, kind of like a recursive feature thing, and then it's going to start two bundles when you start the feature. And then finally, we have the OER that gets generated. So if we take this file and look at it, it's going to have the app.xml file, and then three entries. One entry for the features file, which is got the Maven coordinates embedded in the file system. and then the other two are the bundles that we're including. So that's kind of how the anatomy of an app, kind of how those get built up, and where the code is for each of these things. Now, something else that can be interesting, sort of tangential to what we're looking at right now, but it can be interesting when you're trying to do some debugging. It is possible to attach a Java debugger to the Buck core if you want to inspect some state. That can be done using a file called Buck Java args. So if you create this, these args get passed in to right before Buck gets executed. Okay. And so if you can configure your debugger, get the command line argument for debugging, put that in a file called Buck Java args, and then just tell it to suspend so it doesn't just run off on you. What you'll see is that next time we run Buck, it'll just hang in the beginning, and then you attach your debugger. Attach the debugger, and it should get started. And then what's happened here, you can see as it's parsing the Buck files, it's hit the call to create the rules. We haven't started actually the build yet. We can also stop in the middle of a build step as well. So for example, the Swagger step here. Let this play on. Oh, so every build step, just get rid of this breakpoint. Right. So the reason it didn't hit our execute step is because it didn't actually have to run the execute. It pulled the file out of the cache. But anyway, point is you can attach breakpoints to either the execute steps or the build steps if you need to. But you should remove the Buck Java args if you want to stop debugging, because otherwise it's going to cause it to break every time. Another thing probably worth exploring is how we pull together the whole ONOS tar package. And so that Buck rule is located in Tools, Package, Buck. And so I think we do this almost entirely with gen rules. We define a couple of features that are going to be the core features we want to be installed and loaded in Carafe. We also define a jar, which is the ONOS branding for the CLI, when you see like ONOS instead of just Carafe. And then we also refer to the Carafe so in this case, because the gen rule script is going to be kind of complicated, we actually do that in a separate bash script here. And this is an example of like, could I write a Python script and then expose it via gen rule? Yeah, absolutely, you can. So we do this ONOS prep craft as a bash script, and then we export that file. So now Buck's aware of it, we'll track changes to it. And then we can use that as the first, as the program in our bash script just below. So prep craft basically takes the vanilla craft that it downloads off of the internet, and it injects the branding, the ONOS version, it adds some sources that we provide, like the ONOS command, the initd scripts, that stuff that we looked at yesterday. So that all gets added into the tarball. Then we compile the main ONOS features file, which is going to be what Craft uses to start up API core, CLI, GUI, etc. And then we have another rule called package, where we stage all of the bundles that are going to be required at runtime, more or less. I think there's some that may not get included, but there's some transitive dependencies that get missed, but all the direct dependencies get included by default. And then we also define, so this ONOS package target, this is buck build ONOS. And so if we said buck build tools package ONOS package,
so buck build ONOS and but alias to this target.
Yeah, exactly. So buck build ONOS is just alias to this target. So this is the same tarball that we'll see if we run buck build ONOS. So that was done in the buck config file. You can build aliases to whatever you want. If there's a target that you have to build all the time, you can add .buckconfig.local and write, my cool app or something, and then you don't have to type the whole big path every time. But yeah, same target. Outputs our tools package, ONOS package. This is also where ONOS run is defined. So this runs Graph in a local environment based on extracting the components of the tarball into temp. So that's the tools. Next thing we can talk about is how we get external dependencies, Guava and everything else. So what we have here is a folder called lib. And so in some projects, lib would contain a bunch of jars. In ours, we don't put a bunch of jars in there. So there's a buck file in here. And this defines a couple of feature groups, which are then used to build the features XML snippets, which then get compiled into the features file. But we've got our compile group. So these are the sort of the dependencies that the ONOS project has, ONOS project core apps, whatever, have directly. These are available pretty much across the board for compilation. And they refer here to local targets, Jota Time, Apache Commons, Guava, Netty, etc. And then we define a few other groups, which include some API and other bundles. These are going to get compiled into the features file later. And then you see a remote jar here for every one of those dependencies. So it's got a name. It's going to be //lib, whatever. It's got a file name. It's got the URL is going to be Maven coordinates, so that'll get resolved using the Maven repositories, and then a SHA. And then the Maven chords here probably could have been inferred, but sometimes you want to fetch a dependency which is not using the Maven URL, it's using HTTP, HTTPS, whatever. So Maven coordinates specified here. So building this and fetching the SHAs all by hand is kind of a massive pain. And then if someone wants to upgrade a version of the library, they have to go and figure out the SHA for that and stuff. So it was kind of tedious to build this thing by hand, and so we just wrote a simple script to do that. And what the script does is we just have a JSON representation of the libraries you want to build and all the artifacts you need. So much more compact, easier to upgrade versions, etc. And then we run a script on this, and then it generates a buck file which gets checked in. The reason we do that is because like actually fetching all these artifacts to verify the SHA and generate the buck file takes some time, and it doesn't happen all that often.
It's not part of the source code.
The script is part of the source code, yeah.
Okay.
So that's under ONOS and so this script is called ONOS libgen. It will cd to buck root, and then it'll build the libgen jar under tools build. So it's basically a Java utility we have that does this, and then it just executes it. But tools build libgen. So this project basically basically uses a tool called Ether, which is a Java library for sort of working with Maven repositories. So we basically use that to resolve all the artifacts that have been specified in the deps.json file, and then produce the buck file. Okay. So when someone introduces a new dependency or wants to roll a version or something, the practice is update the JSON file, which is the master, regenerate the buck file, and check it in. Okay. So maybe I'll stop here because I've probably inundated you guys with a ton of stuff, and see if you guys have some questions.
Yeah. Yeah. I mean, we can take some questions and probably have some short break. Then we just have some deep dive on the POM Obsolescence. Yeah.
Yeah. So
then on we'll pass on the ball to Zach.
After lunch or before lunch?
Yeah, before lunch. Like we will finish up with this POM and then we'll break for lunch. And after lunch we'll have the disaggregation done. Probably we'll have Ray then. Then we'll start off with thinking.
So, any Venkat, Alexis, Zach, questions? Overwhelmed?
Yeah.
Sorry.
I myself had some working knowledge and work, so.
Well, I have no question. This is really very, very high level.
Okay.
Okay,
well,
yeah, and you'll have to.
I couldn't follow everything. Yeah, I have no question for the moment.
Okay, yeah, fortunately this is being recorded, so if there's a piece you want to revisit and sort of look at the commands and flaws and stuff, you can always go back, and if you guys have some questions like that hit you later, once sort of absorbed a bit better, then I'm certainly happy to answer them, either in the next couple of days or over email or via Hangouts or something.
Okay, that's fine.
But yeah, I guess the thing that's a little bit frustrating about working with the Buck plugins directly is that there's not a lot of like system architecture documentation that I could find anyway. So a lot of it was kind of reading the source code and kind of tracing through stuff. And once you sort of spend the time doing that, the whole thing kind of makes sense. But I remember kind of being in a position where I was extremely confused for a long time. So definitely, however I can help bridge those gaps.
And I have written a small blog post on how to create or how to migrate an app from the Maven family.
Share this with actually?
Yeah, or else you can just ping it. You can just So this will have, some information what Brian just shared. When I was writing this blog, I just understood what. I just had my own understanding, but it's like after having Brian's session, I understood some part of work. So probably you could go through this page, try to understand things of how to migrate your own app from Maven to Bug family, and if you just revisit this video again, you can make a lot of sense.
Okay,
yeah, so an
I
example.
think this blog will be very, very informative.
Yeah, so an example here, simple single app buck file. OSGI jar just uses all the dependency stuff that was specified, but I mean theoretically you could add that the stuff that gets pre-populated automatically. ONOS app here, there's a lot of stuff that gets pre-populated automatically, but to see kind of how that's working, I think that the best thing for me at least is kind of either have some documentation or even just like the source code, and kind of knowing that OSGI jar and ONOS app are defined as bucklets. You can look at those bucklets and look through the Python code. You can add print statements to the Python code if you want. That's the easiest way to debug the Python side of things. You can add print statements to your buck file for that matter if you want. You can print out variables, whatever, and those will just print out as warnings right on the buck terminal. So for example, for ONOS app here, we say print hello world. HTTP app. So buck targets apps DHCP. So targets is just a command to sort of enumerate all the targets that end up. It's not going to show you the macros as I mentioned. It'll be the targets that Buck's aware of. But you'll see that a print statement here, while it parses the Buck file, it's just going to execute your command. So hello world, for example, was what we printed there. You can have macros, print out stuff, print out variables, probably more useful. But definitely, yeah, the way to debug these Buck files is just print what you want. Print line debugging. Not the most elegant, but most effective in this context, yeah. So do you want to take a 5-minute break and then come back and talk about the POM?
Yeah.
Okay. So we're going to take a short break here, and then in just a couple minutes, we'll be back and we'll talk about what's sort of involved in completing the migration away from Maven.
Yeah, so can we leave the call running?
Yeah, we can leave the call running.
So probably can just pass the. Yes.
All right. So the next thing we wanted to talk about was a little bit more about the POM Obsolescence deep dive. There's a couple of different documents, it seems, for tracking some of the remaining work. So I think Vishwa's got one. I'll show you two, and then we'll get to Vishwa's because it's probably the most on point. But I just wanted to point this out. So there's a ONOS buck build doc. The URL's up here. It's also, I think, been shared with the Brigade on the mailing list previously.
Okay.
But here, so there's a few things sort of on the outstanding items list that we had relating to Buck. One of those items is removing the POM feature XML files. Another one was completing IDE support.
This was part of that document.
I think we actually did this. So this may not be the most up to date, and we might actually want to move. A lot of this is also in Jira as well. There's a Buck epic in Jira that I'll just point out briefly. So backlog. So there's some items in here as well. One of those items is from that Google Doc. I think a lot of them were pulled over here. So this is what we were historically using when we were like trying to scope work into the sprint. And this, I think, is probably the best way to track the work going forward is via the Jira.
Okay.
It also pulled in.
I created another epic for this brigade, so do you want me to remove that and reuse bucket itself?
No, I mean, I think, well, so I think epics are sort of typically focused on specific feature area.
Yeah, so
And
I
this
created one epic for POM Obsolescence.
Oh, for POM Obsolescence, I see. Could be, yeah, you could use that instead, and we could then remove the story here, for example. Yeah, that would be a more targeted epic. That'd be perfectly fine. I think for this brigade, we might consider putting like a label on some of this work and say build an infrastructure brigade. That way you could filter based on all the work across all the epics for the brigade. But
yeah, that is on.
Oh, that's there too. Great. 2 steps ahead. All right. So yeah, there was also a TST meeting where we surfaced some of this stuff. But getting to the meat of this particular topic, which is the POM obsolescence. So currently, we've got a few POMs that we're going to require going forward. Build infrastructure. Okay, great. We've got a few POMs that we want to maintain, and this is for people that are going to want to build artifacts against using Maven against ONOS API and stuff. So there's probably going to be the POM in libxml or in the lib directory, which is going to describe all the external dependencies so that someone can import the POM and get all the transitive dependencies if they're building an app, so that there's they can maintain sort of version compatibility for the libraries that we use. There's probably a POM as like a base POM, which describes some plugins for ONOS. I'm not sure exactly what all these are. There's some POMs for archetypes. But I guess the sort of first blocker from my perspective is we need to get the source code coverage to nearly 100% or 100% before we can start removing POMs from.
Code coverage in the sense like models that are built using bug versus models that are still built using POM.
Right. Yeah. So we have a list here, I guess, that's gotten started. This list is probably actually a little bit longer because it also includes like an incubator, the protobuf work as well.
So Thomas was mentioning about an idea of reaching out to the developers using mailing lists and then ask people to come forward and telling them that they actually use bug or they use Maven.
So I just want to see what is in the epic.
Then after GL.
Right here. Okay, so there's a backlog of work here, which is not maybe complete, but I mean I think the tasks you've identified here are more or less covered. We need to figure out how to get. I think like the highest priority from my perspective is figure out how to get Buck building the entire source code so that we can move developers off of the Maven-based build, because there's some people who are building some things that can't do it. The next thing is probably figure out how to get Eclipse working, because I know there's a lot of developers that like using Eclipse. And then once those 2 things are done, then we can move forward with the process of actually removing the additional POM files for most of the modules.
Yeah. My question is, these two are the only gaps that we face in work, or is there any other unknown gaps?
I think that's more or less the.
We share this with.
Yeah, I think this. Well, this one I share. I'll send the link again, but.
You sent to the menu.
Yeah. So Eclipse ID support. This is not a blocker. Embedded dependencies, some people wanted. Not a blocker though. Well, maybe for building some application. Yeah. So I think it's basically just those two items. Eclipse. Generating the additional POM files that are needed for Maven-based workflows outside, and Sonar. Yeah, so I think that's it. Is these two issues, and then just making sure we produce some POMs that get published for folks.
Because I didn't get it.
Well, we can check later, and I'll just resend it this time.
Okay, so going by this, so can I just give me a deep dive on what is that we are not getting from bug with respect to Eclipse?
So both IntelliJ and Eclipse understand POMs and dependencies and all the other stuff. They can basically build the class path and understand what's sourced, what's test, what's excluded based on the POM structure. And so when you import a project into Eclipse or into IntelliJ and just say this is a Maven-based project, we'll do an analysis of the POM files and be done. Neither IntelliJ or Eclipse understand the buck files to be able to build the class path, source directories, test directories, etc. And so Buck supports generating the IML files directly. And so you'll see that in this particular tree, the module name, apps, ACL, apps, BGP router, etc. Like this was all imported using the Buck project command. So Buck project will generate all the IML files, puts them in place, and then you just open the project in IntelliJ as an existing project. For Eclipse, you need to generate .classPath files on a per module basis so that it knows what the class path is for each module so that it can inject that class path when it's doing its local compilation and trying to figure out whether there's exceptions.
So generally we have to generate .c project files. The .class path.
Yeah. So either we need to generate the .classPath files, or we need to figure out how to convert the IntelliJ project into an Eclipse-based project, or otherwise, generate. Yeah. Basically, and Buck project is a command suite that used to support the ClassPath option, but I'm not sure why they deprecated it, and I'm not sure if they.
When you want Eclipse to build the project using Buck.
I don't think we care about being able to build a project using Buck and Eclipse.
Just navigate.
Just navigate through the source code, see the modules, be able to actually like, you know, understand that.
Okay. So we just have a comment. Not necessarily. Okay. Certain models have assembly requirements that are not simply met with Buck. So this is related to the transfer dependencies. If that's the case, then that's how the Buck ideology works, right? Buck doesn't care about transfer dependencies. It wants you to specifically, I mean, it wants you to implicitly specify the dependency. So then, what are these dependencies?
So for these modules, if you scroll down, right? So for example, apps BMV2 demo.
I think that is this is with the P4, right? So let us take some easy project. Either let's take this OF agent or OpenStack network.
Well, so okay. I mean, I think this one explains it right here. Right? For scroll here, so we're talking about what the blockers are for some of the remaining modules. One of the blockers for BMV2 demo, I believe, is getting the Thrift models auto-generated and used. For BMV2, same thing, Thrift compiler. There's another area here we should add, which is incubator protobuf.
Based on what Aaron or something? The DLP system? Yeah. Yeah, of course. Then you should have the same problem with Yang as well, right? Even Yang has a controller.
Yeah, so we actually have the ability to build the Yang model through a plugin that we wrote.
So can we use the same ideology here?
Yep. Yeah, it's not that hard. But yeah, they wrote a plugin to do. I worked with some of the guys from Huawei in India to write a plugin in Yang.
Plugin in the sense another rule?
Native.
Okay.
And we could do the same thing for Thrift and for. Actually, I think there may already be some support for Thrift in Buck. We just need to use it. And I think for gRPC, we would need to have a rule for that. Okay. We could also look at like latest master and see if someone has added it. So then we could just merge the latest master and maybe get some stuff for free. This OpenStack networking thing with embedded dependencies, that's a feature of OSGI, which is kind of a nightmare to be honest, but it would be relatively easy to implement. I just have ideological oppositions to it.
Okay. So
basically the idea with required dependency is it enables you to embed a jar in your jar. So you have an OSGI compliant jar. You add an entry to your manifest called embedded dependencies, and then you specify within your jar the name, the path of another jar, which is just a random collection of sources and crap. So instead of using the standard OSGI import-export package mechanism, you slam a jar in, and then that jar gets added to the class path for the bundle when it started. And so it basically enables you to, I don't know, depend on a jar, inject a jar that you don't feel like making OSGI compliant and don't want to expose outside of your application.
Okay, so that is not global. I mean,
no, it's
embedding a jar inside a jar is not global using Buck.
It's doable.
Then why do we have an icon here?
I didn't want to do it. No, I mean it's just work, right? I mean someone needs to do it. It's not a feature that is supported out of the box. It would need to be a just a little bit of work to extend the ONOS jar interface to accept embedded dependencies. You point at those embedded dependencies and then just have them be included in the jar package and included in the manifest. So it's some amount of work to work that through and make it possible. But I mean, like everything else, right? It's not impossible. It's not even that terribly difficult. There's some work that needs to be done.
Okay, so the idea is to extend the
ONOS jar rule.
To have embedded dependencies.
Right.
And that is the case for even these two.
Those two, yeah. So those two need embedded dependencies. The other ones need Thrift and Protalk compilers. Then the other ones are 10B. I don't know what 10B requires. Kafka integration, not sure what that requires. There are a few other modules, I guess, that aren't built using Buck, but VTI driver using Buck, but it's commented out.
For this, extend
And that basically is add an argument to the build rule for ARG, add the option to the macro, so it can be passed through. Then on the other side, it'd probably be adding a command line, adding a parameter to the invocation to bind, and then also marking those jars for inclusion in the that is used to create the jar.
So we start with either the protocol design or the compiler design or this one.
Yeah, and like I said, for Thrift, there may already have support for it, and for gRPC, it's possible there's support for it as well, but I mean, I'm not sure.
Okay.
Yeah. I think that's more or less the POM obsolescence activity. What do you want to tackle next?
I think we are good. It's already 12, so let us take a break. We'll take a lunch break and then we'll come back to wave 1. And then, so Zach, could you take us through the code disaggregation using repo after lunch?
I am not familiar with the code disaggregation, but I can tell about repo.
Yeah.
Do we want to do one before the other, or?
Yeah, so probably a Hello World or deep dive repo session would be good.
It should be pretty quick.
Okay.
Because it basically it's describing the tools that we'd use for the disaggregation. and how they're being used in other places. So yeah, I'm not sure whether I should go first or second.
Yeah, we'll have to get Ray here, so until he's here, probably we could use that time to run this one.
Well, do you want to see where we're at after lunch, or
We are good if anyone, either you or Ray take us through the Jenkins story.
better if you do, because I have less similarity there. Okay, well, I don't care. What do you want to put? You want to do the repo stuff right after lunch?
Yeah.
Okay. Let's do that.
Okay, that sounds good.
So we'll do that right after lunch, and then we'll talk about code disaggregation after that, take a break, and then have Ray walk us through pipeline, and then have a quick break, and then maybe talk about the K-release stuff. That works for you guys. Okay. Yeah. So let's reconvene at 1 p.m. Pacific, Pacific Daylight, Mountain Standard, in 1 hour.
All right. See you later.
Great.
All right.
See you.
Sounds good. Bye, guys.
Bye.